Today we're back in section 9.2, working on number 46. In a recent year, 73% of first-year college students responding to a national survey identified being very well off financially as an important personal goal. A state university finds that 132 of an SRS of 200 of its first-year students say that this goal is important. Is there convincing evidence at the alpha equal to 0.05 significance level that the proportion of all first-year students at this university who think being very well off is important differs from the national value of 73%? Now going back through this problem, looking specifically at the key information that they're giving us, the hints that they're giving us, we're told that there's 73% of first-year college students involved in this. So that's giving us our population, first-year college students. Then we know that 132 of an SRS of 200. So we know what our X is, what our N is, and we also know that there was an SRS taken. We're told that we have an alpha of 0.05, so that's what we're going to use to make our decision on. And we're checking to see if it differs from the national value. So that means we're checking to see a not equal to alternative hypothesis, which gives us a two-tailed test as opposed to the one-tailed test that we had done before. So next is to write our hypotheses. So our null hypothesis is going to be that P is equal to 0.73. Our alternative is that P is not equal to 0.73. And I'm going to include in this that my alpha level is set to be 0.05. I know it was written up here, but I want to include it in my response as well, because that's what it's setting the stage for everything. Remember that our P stands for our true proportion of all first-year students at this university who think being very well off is important. Now, as soon as we've done that, we've set the stage for everything. We're all set and ready to go. We know that because we have a proportion here, we want to use a one proportion z-test, but before we can do that, we have to check the conditions. So checking those conditions, we have that an SRS of 200 first-year students was taken. We're going to assume that 200 is less than 10% of all first-year students at this university. Doing our N times P condition, we can see that they're both definitely greater than or equal to 10. So we're going to be able to use a one proportion z-test. Now again, remember, we should find our z-score to begin with. So we're going to go through finding that. Now I just want to remind you guys again that everything that you need for these is all in your resource packet. Again, it's just a matter of you knowing how to use it. So right here in our inference, this is the second page, your test statistic is always the statistic minus the parameter divided by the standard deviation of the statistic. In this case, our statistic is our p hat minus our parameter, which is p, divided by our standard deviation of the statistic, which again, show that again here, is the square root of p times 1 minus p over n. So we just go to the data that we have for this. Our p hat comes from the information given, which was 132 over 200. And then our P comes straight from our hypotheses. And our N we know was 200. So after putting all that information into my calculator, I was able to get that my z-score is going to be negative 2.23. Now I just wanted to show you again how you can do this by hand, because last time I know I only focused on using the calculator. So just like you did before, you would go to table A. I would look for negative 2.23, so 2.2 moving over to 3, I get 0.0129. So that means in my normal curve, at this value of negative 2.23, I have 0.0129 in this tail right here. But because this is a not equal to alternative hypothesis, I have two tails happening. If this was just a greater than or less than, I'd be done right there. I would just pull that probability. But because it's two-tailed, I have that probability, same thing happening over here on this side. So this also has a probability of 0.0129, which gives me an actual p-value of 0.0258. And then that's what I would use to make my decision. Notice that 0.0258 is less than my 0.05 alpha level, so that means that I would reject the null hypothesis. And then my conclusion would be written from there. So your work could be shown this way, or your work could be shown this way. Now notice in this one I did say that I'm using technology, but when you do that, make sure that you write down everything that your calculator gives you out. So if I set all of this up in my calculator and I hit calculate, the calculator gives out all of this. Now notice what I'm writing down is what I initially put into my calculator and then what I later got out of my calculator, my z-score and my p. All of that stuff is being written down as part of my answer. And then I go to my conclusion. There is statistically significant evidence to suggest a proportion of students at this university who think being very well off is important, differs from the national average at 0.73. So either way you can show your work, just make sure you're giving enough information that the reader can follow what's been done.